Sometimes you see these headlines like Starlink damaging the ozone layer or satellites falling every day.
Oh, yeah. They definitely grab your attention.
Right. And you kind of wonder, okay, what's the real story behind Elon Musk's Starlink project?
Absolutely. It's this huge plan for global internet, but yeah, the scale brings up some serious questions. So today, in this deep dive, we want to cut through some of that
Look
noise.
past the scary headlines, basically.
Exactly, and figure out what the experts are actually saying. We're mainly looking at an analysis from Sabine Hassenfelder's recent video. She really digs into the science.
Okay, good. So where do we start? The sheer number of these things seems like the obvious place.
Definitely. So right now, early 2025, we're talking over 7,000 Starlink satellites whizzing around up there in low Earth orbit.
7,000. And how does that compare to, like, everything else?
Well, get this. That's roughly 3/4 of all active satellites currently in orbit.
Wow. 3 out of every 4.
You there?
That's incredible. And SpaceX isn't stopping there right now.
Not even close. They already have permission for another 12,000, and they've put in applications for potentially over 40,000 in total.
40,000 from just one company. Good grief.
And it's not just them. You've got Amazon with Project Kuiper, SpaceSail, others planning their own big constellations.
So the sky's going to get pretty crowded then.
Extremely. There's this Harvard astrophysicist, Jonathan McDowell, who estimates we could be looking at something like 100,000 satellites by the end of the decade.
100,000. Okay. Just trying to picture that. What does that even mean? I mean, apart from bumping into each other.
Well, that's a big part of it. The collision risk goes way up, but also just managing that traffic. And, well, what happens when these satellites reach the end of their life? Which brings us to those falling satellite headlines.
Yeah, that sounded pretty bad. Like things are just dropping out of the sky uncontrolled.
It does sound alarming, but the reality is a bit different. It's true that maybe 4 or 5 Starlink satellites re-enter the atmosphere every day.
4 or 5 a day.
Yeah, but it's planned. SpaceX is deliberately deorbiting the older ones. It's like a controlled retirement. They burn up high in the atmosphere.
Okay, so it's not random space junk hitting the ground.
Yeah.
That's somewhat reassuring.
For now, yeah. But the issue Sabine Hassenfelder flags is, even when they burn up, that material doesn't just, disappear.
Right, it stays up there.
Exactly. It gets spread out very thinly in the upper atmosphere. And the key thing is what they're made of. Unlike natural meteorites, these satellites have a lot of aluminum.
Aluminum. Okay, why does that matter?
So there's research from the University of Southern California. They found that each satellite, when it burns up, releases about 30 kilograms, that's like 66 pounds, of aluminum oxide nanoparticles.
30 kilos per satellite.
Yeah.
And there are thousands planned, burning up regularly.
Precisely. If you scale that up with the planned expansion, you could be looking at over 360 metric tons of this stuff accumulating every year.
360 tons. That sounds a lot. What's the worry with aluminum oxide?
The main concern is it can act as a catalyst. It helps chemical reactions happen. And one reaction it might trigger is the release of chlorine.
Ah, chlorine. And chlorine eats ozone, right? That's the
It's
connection.
a potential link, yeah. The scientists behind that study said the impact is, quote, poorly understood, but could be significant.
So not a definite Starlink is destroying the ozone layer situation yet, but need to look at this very carefully kind of thing?
Exactly that. It's a potential risk tied directly to the sheer scale and the disposal method. Needs more research, for sure.
Okay. Now, what about that other thing I think I saw mentioned?
Right.
Something about conductive dust messing with the Earth's magnetic field.
Yes. That idea came up last year. A scientist suggested that this accumulating metal dust, because it's conductive, could potentially interfere with our magnetosphere.
Sounds also bad.
It does, but there's a big caveat here. That research, it was presented as a preprint. It hasn't actually gone through the formal peer review process and been published in a journal.
Ah, okay. So it hasn't had that layer of scrutiny from other scientists yet.
Correct. Peer review is really crucial for validating scientific claims. So while the idea is out there, its reliability is kind of questionable at this point. Hassenfelder also noted this lack of peer review as a reason for caution.
Got it. So maybe less certain than the aluminum oxide issue. Let's switch gears then to something astronomers have definitely been vocal about: the brightness.
Oh, yeah, that was a huge issue initially. Especially around dawn and dusk, these low-orbit satellites would reflect sunlight and create bright streaks across long-exposure telescope images.
Ruining observations, basically.
Pretty much. A real headache for astronomers trying to capture faint, distant objects.
But didn't SpaceX say they'd fix that?
They did, and to be fair, they have made significant improvements. The second-gen satellites have better coatings, different orientations for the solar panels, things to make them darker.
And did it work?
To a large extent, yes. They're apparently about one-fifth as bright visually as the original ones, a big step.
Okay, so problem solved for astronomers.
Well, not quite. It seems solving one problem sort of created another one. These newer, dimmer satellites, they're actually emitting more radio waves.
Oh, come on, really?
Yeah, specifically in the 100 to 200 megahertz range. And that's a band radio telescopes rely on heavily to study the universe.
So they went from being too easy to see to being too loud, electronically speaking.
That's a good way to put it. Sabine Hossenfelder had a great analogy, like stealth bagpipes. Harder to spot visually, but much louder in the radio spectrum.
Stealth bagpipes. I like that. How much louder are we talking?
Now, the reports suggest potentially up to 32 times stronger radio emissions from these Gen 2 satellites. The thinking is maybe less effective shielding on the electronics.
Okay, so visual pollution traded for radio pollution.
Yeah.
Are they working on fixing this now?
Yes, they are. Similar to the brightness issue, they seem to be taking it seriously. They're testing a system where observatories basically share their viewing schedules.
Like, hey, SpaceX, we're looking over here for the next hour. Could you maybe not beam stuff at us?
Sort of, yeah. SpaceX then tries to direct the satellite transmissions away from the telescopes during those critical times. It's being used with places like the Very Large Array in New Mexico.
Is that actually working? Seems complicated.
Early signs are positive. There was a study showing this coordination can cut down the radio interference by more than 2 orders of magnitude, so like over 99%.
Wow, okay. That's significant.
Yeah.
So it's manageable, but requires ongoing effort and collaboration.
Absolutely. It's not a perfect fix, doesn't eliminate it completely, but it shows that mitigation is possible.
All right, so we've got the huge numbers, the planned deorbiting causing aluminum oxide buildup with potential ozone risks, the less certain magnetosphere thing, and then the astronomy issues: first brightness, now radio noise, but with fixes being worked on.
That pretty much covers the main points from Hossenfelder's analysis.
So pulling it all together, what's the final verdict? How worried should we, actually be?
Well, Hossenfelder's overall take was quite measured. She basically said scientists aren't particularly alarmed yet, but they are, quote, preventively concerned.
Preventively concerned.
Yeah.
Yeah.
On her own sort of worry scale, she put it at a 1 out of 10.
A 1. Okay, so definitely not time to panic.
No, not lose sleep over it territory, according to her. But it clearly highlights areas where we need ongoing research, monitoring, and responsible development.
Right. So summarizing then, legitimate concerns about the scale, about the atmosphere chemistry, about impacts on science, but also active efforts to understand and mitigate. It's complex.
Very much so. It's a dynamic situation. The technology is racing ahead, and the science trying to understand the consequences is working hard to keep up.
It definitely leaves you thinking. As we keep launching more and more of these things, not just Starlink, but others too, for the global connectivity push.
Yeah.
What kind of global rules or, long-term environmental planning do we need, to make sure we're balancing this amazing technology with actually looking after the planet and the space around it?
That's the million-dollar question, isn't it? How do we manage this new era of mega constellations responsibly on a global scale? Definitely something for all of us to think about.